Hey guys, it's Raz again. Okay, so today we get to make the shift into not talking about all biological populations, but talking about human populations in particular. And what we're going to focus on today is how we can predict how human populations are going to change, look at how they've changed over time, and then shift into sort of how that has become what we call the demographic transition model. So today is going to focus just on how populations of humans change. Now, the guy behind me, his name is Thomas Malthus, and Thomas Malthus came out with an idea a while back that he said, hey, the production of food right now is linear, right? It's increasing at a linear rate, but the human population is increasing exponentially, which means that at some point those lines are going to cross. We are going to have a massive catastrophe where we're not going to be able to feed our population. And he had hypothesized that maybe that was going to be humans' carrying capacity, was going to be the amount of food that we could create for our people. Now, that was fine, but we've had a lot of technological advancement. So what we figured out is that our brains over time have altered the human's carrying capacity. So when we figured out how to create nitrogen containing fertilizer back in the early 1900s, we dramatically increased the food supply. And you can see in that graph right there, that little jump up, that's what that's showing. We can also see an increase recently with genetically modified foods. So genetically modified foods are more pest resistant. We can get more yield per acre of farmland. We get a lot more for more bang for our buck, if you will. So we have continued to get these jumps where food production is still increasing linearly, but we have these like leaps of it. So we've kept up for the most part. Not all over the world, but for the most part. And again, I showed you guys this in class. We're just sort of seeing that if you look at kind of our cereal yields, like how much of the barley, wheat, oats, those kind of things that we have put out, it has been increasing exponentially in recent years. And again, that's partly due to our technological advancements. So I mentioned, we were talking about biological populations, right? That we look at immigrations and birth to figure out growth, emigrations and death to figure out what we're losing, and we can figure out kind of what's happening with population. It's the same exact thing with humans. All of those things still apply. But when we're talking specifically about human population and trends, we call that demography. And again, if you kind of look at these, we know that right now human population is increasing exponentially. You can see that graph up in the upper left there. That's kind of back through recorded human history. So you can see we're on the whoop. And then you've got birth rate and death rates for current world birth rates and death rates. So we still have a higher birth rate than death rates. So our population is still increasing, although our birth rates are coming down and our death rates have relatively stabilized, if not kind of predicted to increase a little bit. So we are anticipating that our population growth is going to slow soon. But obviously, as of right now, we're still increasing pretty significantly. Now, we're going to do some of this in class, so I'm not going to spend a ton of time talking about it now, but basically we can figure out using something called the rule of 70, the amount of time in years it will take for a population to double, assuming that everything is sort of stable. And all we need to know is the value of R. And R is just a percentage that is figuring out the rate of population change. I'm going to go through the math in class. We got a whole day on it. Don't worry about it here, except to know that equation. That's the important part. All right. So when we're looking at how populations are going to change, a big thing is looking at fertility rate and the total fertility rate. Just to get some kind of words out there, I'm going to give you these three definitions. Before I do, the little disclaimer, I'm using the terminology that you would see on an AP test. Please know when I say woman, it's really person with uterus, right? We can kind of, I have to use these terms, but we'll use other ones in class. So when we're talking about total fertility rate, we're looking at just the average number of children a person can have. Higher birth rates, right, are going to mean higher fertility rates. And that means the population is going to grow more. We also have to take into account infant mortality rate, which we abbreviate IMR, which is the number of deaths in children under the age of 1 per 1,000. So we see higher infant mortality rates in less developed countries because they have less access to, sanitation and to healthcare and that sort of thing. And that's going to relate to the replacement fertility level. So replacement fertility level is kind of a weird concept, right? Because it's kind of thinking about, well, if there's two people that are having children, the replacement level of fertility would be what it would take to replace them, which on the surface kind of sounds like, okay, it's going to be two, but it's not, because we have to take into account infant mortality rate. So generally, we say that replacement fertility is about 2.1, meaning that each person that can have children would have about 2.1 children. I know you can't have 0.1 children, it's an average. And that would keep the population stable, not increasing. Now, that's typically more of a developed country. That replacement fertility level is going to go up slightly in less developed countries because there's a higher rate of infant mortality. So we have to account for that in that figure. So sometimes you'll see replacement fertility levels of 2.4 and 2.5. You can assume that those are developing countries. And this is just kind of showing you around the world. Now, these are slightly older graphs. Again, I went with what was in your book, but the trends are still relatively the same. So total fertility rate, you can see on the left, is highest in African countries right now, and some of like the Middle Eastern countries. And if you look at infant mortality rates, they're also high sort of in those similar areas. So we'll talk about that in class. All right. And this is just sort of looking at infant mortality rate over time. Happily, it has continued to decrease around the world, right? If you look back at 1990, worldwide, we had about a 6% infant mortality rate. Now we've got 2017, it's come down even more, but we're at about a 3%, which is still high, but it's better. And we're getting better at that because we've got better access again to clean water and to healthcare and a more reliable food supply to feed that population. Now, interestingly, as that infant mortality rate has come down, notice what's happened to the amount of children per woman. In 1950, we were looking at about 5 children per family. In 2015, we were down to, 2.5 or so, between 2 and 3. So as infant mortality rate has come down, so has the number of children per woman. Now, remember, correlation does not equal causation. Just because they seem to be aligned doesn't mean that one is causing another. It's a complex issue and there's a lot going on. But I want you to make note of that because we'll come back and talk about this in class. All right, so if we're looking at total fertility rate, I just kind of mentioned some of this. Here are some other factors that go into it. One of the factors that's going to influence it is the level of development of the country. So developed and wealthy nations tend to have a lower fertility rate, and that's for a lot of reasons, but most of them have to do with the person that's having the children. So if we have women that have more educational access and more economic opportunities, they tend to delay the start of their families, right? If you're going to college until you're 21, 22, you may not be thinking about starting a family until much after that. We also have better access to family planning and contraceptives. So the ability to control when people have children has made it so that we have fewer because we tend to wait a little bit longer. That's kind of that later age of first pregnancy. And then, so it's a strange thought, but right. So my grandparents grew up as farmers and they grew up on a potato farm. And my grandfather, I think, is one of 17 and my grandmother is around the same. Like, I think she's actually more. She might be one of 19. They had a lot of kids because they needed help on the farm, right? We have less need for that now. Even farming communities tend to rely more on industrial agriculture, which we're going to talk about, right? So there's less of a need for lots of kids. Moving over, we also have government policy that can play a huge role for good and bad in total fertility rates, right? Most of us have heard of China's one-child policy. It's up to 2 now, kind of. We've seen places where there's been forced sterilizations, which is horrific. There's actually some places too that will give tax incentives to families with fewer children or give out loans to women without children to start businesses. We're going to get into all the government policy in a little bit more, but know that obviously that is going to impact total fertility rate. And this is just some of, again, those graphs I just told you about. So you can see that if you look at the average income kind of per country and the births per woman, as we get more affluent, we see the amount of children per family come down. And same here. If you look at the average years of schooling, as those numbers come down, we see the number of children come down. So more schooling leads to less children per family, right? And again, I already kind of talked about the reasons for that. Now, I actually made this slide before we hit officially 8 billion. So we have officially hit 8 billion. We talked about that. I like to show this graph too to look at where the human population is. Because if you look at the first two most populous nations, China and India, they're both over a million people. I'm sorry, a billion people, way over a million. They're both over a billion themselves. Look at the US, which is number 3. We dropped down to less than 500,000. There is a huge gap there. Again, we'll talk about why in a little bit. So I'm going to pause here. I'm going to make a second video for age structure diagrams. It'll be shorter, but go catch your breath, take a breather. We'll be back in a little bit.